Starting with numerical number 5.3. Such type of numericals you won't find in your paper as 11th standard is considered. Three particles A, B and C, each having mass m, are kept along a straight line. So here you have three particles which are kept along straight line A, B and C. Now a fourth, AB and BC is equal to L. A fourth particle D is kept on the perpendicular bisector of AC. Now suppose this is perpendicular bisector. So here is point D which is on perpendicular bisector of this side AC, and which is at a distance L from D. So this distance is also L. Now determine the gravitational force on D due to these 3 points. Okay, and all the 3 points have mass m. Even D has mass m. So now in this case, the force, a gravitational force between these 2 points, then gravitational force between these 2 points, and gravitational force between those 2 points. So what is asked? Determine the gravitational force on D. So the gravitational force, here the gravitational force is acting on point D due to A. So first I'll find force due to A, then it will be force due to mass B, force due to particle number or particle C. What is the formula? G, masses of both the particles, mass for A and mass for D is same, upon the distance, square of the distance. Now the distance between AD. Now here, since it is a perpendicular bisector, so this angle will be 90 degree. Okay, and since this is 90, we can apply Pythagoras theorem. AD square will be equal to AB square plus BD square. AB, that is L square, and BD is also L, so L square, it is 2L square. So AD will be equal to square root of 2L square, that is square root of 2, and L out of square root, that is AD. And since D is on the point which is a perpendicular bisector, so AD is equal to DC. So I can write AD is equal to DC, which is equal to L root 2. So now I have the value of this term, this side, that is AD and CD. So here the distance between them, square. So this will give me Gm square upon 2L square. This is the gravitational force on point D due to A, or the gravitational force between them, which is directed towards A. Same, G m square. Now force due to B. Now here in this case, the distance is L. So mass of both the particles, mass of B, mass of D, so m square, and the square of the distance, that is L, so L square. Here due to C, so here the distance between CD or DC is root 2L, same as AD. So here the gravitational force is going to be same. And here when you see for DC, the gravitational force is acting towards C, here it is acting towards B. So we have the direction. Now we have the forces. We will resolve the force into 2 components. One along, draw the diagram over here. One along x-axis. So when I consider for point D, we have 2 directions for x-axis, either this side or this side. So we will be calculating force on D along horizontal, and we will also calculate force on D along vertical. So let's see, along horizontal we will have force due to A and force due to C. Force due to A and force due to C. Where is it? Force due to A is Gm square 2L square. Gm square 2L square plus, I'll write I over here, I hat, and here I have done something. Gm square, and due to C again it is same, 2L square I hat. Now while going from A to C, the direction is towards this side, but here if you notice the direction is along negative x-axis, so here I'll have minus I. But when we consider from B to C, that is when we are approaching C point, when we approach this side, this direction and this direction is same, so here it will be positive I. Now next thing, this is 90, this side is L, this side is L, so this makes this triangle an isosceles triangle. For isosceles triangle, this is 45 45 90, isosceles triangle. Okay, now here if you notice, this is making it an alternate angle, so even this is 45 degree. Okay, now we need this side because force acting on D due to A, means I am in need of this side, this one. But where we are working, we are working along horizontal, that is AB. Which formula gives us horizontal, or which formula gives us this adjacent? That is cos theta is adjacent upon hypotenuse. So here cos 45, in this case what is adjacent? Adjacent is AB upon hypotenuse. Hypotenuse is AD. So what is AB? AB and AD. See this, AB and AD. We are getting these two sides, so that is the reason we are taking here cos 45. Now when we look for C, we need this BC and we need this CD. So this is 45. Again, what is going to give me that? Cos 45. Cos 45. Now what is the value of cos 45? Cos 45 is 1 upon root 2 and 2L square minus I, Gm square 2L square cos 45 I. Cos 45 is 1 upon root 2 plus, both the terms are same, they will cancel out each other and you will get 0. There's no need to come to this substitution of cos 45. You can directly write 0 over here, because if you check this whole term and this whole term, here you have plus. Since I did not have any space over here to write, so I have written it here. So this whole term and this whole term are same. It is just this is negative and this is positive. So these two terms will cancel out each other and you will get 0. Means the force acting on D point due to x-axis, means the forces or the particles along x-axis are not applying any force on D. Now let's check when the particles are along vertical. How much force are they applying? So along vertical we have A, B and C. Initially we were checking along x-axis. Now we are checking along vertical side, that is downwards. This was my x-axis and this is my y-axis. Now if you notice, y-axis is towards upward, but here all the forces are traveling towards downward. So here force on D along vertical component will be Gn square 2L square because of A, J minus y minus J is because we are working on vertical component, and minus because the direction for A is downward and y is directing upward, plus Gn square L square again minus J hat plus Gn square 2L square and plus j. Sorry, again minus j, because all the three directions are towards downward and vertical component is towards upward. We will have cos 45, cos 45 and cos 45. Why cos 45? While coming down, we need this side. This is 45 and even this is 45. While coming down, what we need, that is hypotenuse and vertical. So here 45, cos 45 is adjacent upon hypotenuse. Adjacent side is BD and hypotenuse is AD. Okay, so here also we will take cos 45. Now while coming towards, when you consider force due to B, force due to B, there is no angle between B and D. There is an angle of 45 between A and D, angle of 45 between C and D, but no angle between B and D. So here we will not write any cos 45. While considering force due to C, force due to C, that is gm2l square. gm2l square, again what we need, this vertical component and this hypotenuse. So this is also 45 because this angle is 45, 45, 90. So this is 45. Cos 45 is adjacent and hypotenuse. So now we have gn square cos 45 is 1 upon 2 root 2 L square minus j plus gn square L square minus j plus gn square 2 root 2 L square minus j. Cos 45 is 1 upon root 2. Now what we have in common? gm square and L square. gm square, L square, gm square, L square, gm square and L square. So I'll remove that in common. gm square, L square. What is inside bracket? 1 upon 2 root 2 plus 1 from here plus 1 upon 2 root 2. 1 upon 2 root 2 and outside bracket it will be minus j. So gm square, L square, 1 upon 2 root 2, 1 upon 2 root 2, 1 upon 2 root 2 plus 1 upon 2 root 2 plus 1 minus j. So this will give me 1 upon, not 1 upon, 2 upon 2 root 2 plus 1. Since the base is same, so I'll write it once and 1 plus 1 will give me 2. This 2 got cancelled. So it is gm square, L square, 1 upon root 2 plus 1 minus j. This will be the force acting on particle D due to this 3, not due to this 3, due to B. Okay, this will be the force acting on particle D due to vertical component, that is B, and that is along dB towards downward, and along y-axis if you notice the direction is upward, and when you calculate towards D to B it is downward. So that is the reason here you have negative sign. So here you have only force on acting particle D due to vertical component, that is D.